Hello and welcome to Microsoft Hates Greg. My name is Greg Deckler, and today we're going to be providing an update on Calculate Challenge Round 1. Has it been solved? Let's find out. All right, so it's been over a week since I posted this Calculate Challenge Round 1 and made my first video on it. You know, the gloves are off and all of that. And so it's gotten quite a bit of responses here, mostly Lutz Bendlin and Alexis Olsen, as well as Tamer Juma, have been in on this. And congratulations to Alexis Olsen, who I would say has partially solved this. And you know, you can go out there, and I'll link this obviously in the details if you want to go out and take your own look at it. What Alexis did was he provided a solution for one of the problems year to date. And so right here I have like Alexis Olsen's year to date calculate and calculate 2. And so let's take a look at the original problem, or the original solution to this, which is like no calculate this one as well as no calculate. It's the same thing. It's just where the filter clause and all of that sort of stuff, or what exactly it's using essentially. But so let's take a look at this one. They're both basically the same. So in the no calculate solution, to get year to date, right, we'd get the max of our date in context. We get the year of that date. We then perform a summarize across all of the fact table by order date, where the year of the order date, you know, by the year of the order date, we include that in the table. And then we do the sales and the internet sales, and that's just sum of the sales, right? It's the same thing as if I go here, I'm just summing fact internet sales sum. That is exactly what internet sales measure does. Okay, and then once I have that, I can do a SumX. I can just filter that for the year is equal to the year that I am, and the order date is less than or equal to the date, and that's going to give me year to date, right? I'm just summing the sales, which is this column. Now, if you think about this, the way this is creating a virtual table, right, in this table bar. And then inside that virtual table, it includes the summarized internet sales by order date, okay? And then I can just do a SumX across that, right? Now, Alexis Olsen's solution to this, and we'll take a look at his original one. It looks very similar, I would say, to the no calculate approach, where it's create some variables, create a table var. He's basically kind of doing the same thing, where he's summarizing fact internet sales by year and by date, right? And he's using the dates table, which is linked to the order date. And then he does a window function across here as a filter, more or less. And then he does a calculate. Now, this is so similar to the no calculate approach, you could actually replace this with a SumX of your date range and then internet sales, right? You just kind of flip those parameters, use a SumX, and it'll return you the same result. That's how similar it is to the no calculate approach. But this is different, right? And it does leverage calculate. It's just maybe a little bit weird for some people to see it this way. But what this is doing, instead of your summing across the virtual table and the value that's in that virtual table, what this is doing instead, by using calculate, is that it's using this date range, this filter, against the original table, right? And then executing this measure against it. But it's using this as a filter clause for the original table, is what's happening. So it's different. It's very much different than how the SumX works. And it does leverage calculate, right? And this is a little bit easier to understand, because one of my complaints with the window is like, well, window was just invented like a year ago. So he's like, well, you can do it with filter as well, right? Filter all dates year equal to the current year, dates less than or equal to current. This looks even more like a no calculate, right? Create some vars, create a table var, do a SumX across it. Only this time it's using calculate. Now, and this does solve the performance impacts. And just in case you're wondering, start recording, refresh the visuals. Let's do that one more time so it's not just. All right, so here we go. So we have the no calculate version. This one's 166 as far as milliseconds as far as the DAX query, 165, 206, right, for the calculate version. The other one's 3/10. So the filter one is a little slower than using the Windows function, but still in the same ballpark, right? And I did this for all of these different. I created measures for all of these different the 12 different measures that are in here. And for all the TD, right, the to date ones, they all come out kind of the same. The calculate version's a little slower than SumX, but it's still in the same ballpark, right? We're not talking like an order of magnitude difference in this case. Now, you also may be wondering why the original calculate measures took so long. And it's the reason why I picked this particular problem for Calculate to solve. And that is because in the downfall to no calculate, that video I did a few videos ago, and you can go back and watch that. The real downfall of the no calculate approach, it wasn't the no calculate approach per se, it was that the DAX query engine made some poor choices when it came to when you wrote the no calculate code. It did some really poor choices, and which caused the no calculate version to take longer than calculate. Whereas in the calculate version, it didn't make those poor choices. Or if you use calculate table, it caused the query engine to go a different path and create a better query plan. But what's on display here is that if you just use like your normal, like what you would normal think of as far as, year to date. So let's see if I can bring it up. Whereas you normally say, calculate would look kind of like this, right? Where you do a filter all dates, year. This creates a really poor query plan, all right? It's the same problem, okay? So this whole concept of performance and everything really boils down to a large degree on the query plan created by the DAX query engine. And if it does poor choices, you're going to get poor performance. If it does good choices, you're going to get good performance. So unless everybody think that, oh, well, no calculate is it's subject to the query engine making poor decisions. Well, calculate has the same problem, right? Just because you're using calculate doesn't mean that the query engine is going to make good decisions, and that's why this performs really terribly versus Alexis Olson's solutions. Back up here at the top, this tends to guide the query engine down a better path, okay? And it creates a better query. In fact, it's kind of interesting in terms of Alexis actually complains about this. Let me find it. So here it is. So something, right? The query planner is doing weird things. And he actually displays this out. And of course, I already knew this, and that's why I responded with a troll face, right? I already knew that it was creating a bad query plan behind the scenes, and that there wasn't really a good way around it except kind of the no calculate approach, which Alexis basically implemented just with calculate and not no calculate. Now, the reason congratulations on Alexis Olson for figuring all that out. Tamer Juma also came to the same conclusion, had a slightly different take on it as far as using cross join with a none in order to basically what the query engine is doing is doing a Cartesian product between the dates table and the fact table, and that just blows up the query plan and it's really bad performance. Okay, so now when I tried to do this, however, let's stop this, clear it. So there's really two types of calculations. There's the TD, the to date calculations, and I was able to get this to work with quarter to date, month to date, week to date. Week to date's maybe a little bit different, and also all of these previous, quarter to date, previous month to date, previous week to date, previous year to date. All of those can be solved more or less with Alexis Olson's, solution to this. And the results are surprisingly kind of consistent in that they're not as fast as the no calculate approach, as a pure no calculate approach, but they're within reasonable magnitudes, right? We're talking like maybe some of them are twice as slow or something like that, but they're not orders of magnitude slower. However, for things like previous year, previous quarter, previous month, and previous week, the results are a little different. So Alexis didn't want to create all 12 of these different things, right? So I went ahead and took his solution and put created them myself to test out the performance. But when I did them for previous year, previous quarter, previous month, and previous week, the results are a little different. All right, so I'll show you what it looks like as far as previous year. So doing a summarize all. So I get the min and max dates in context. I filter all the dates. So it's very, using filter, but I could use window here, I suppose. If I'm using filter greater than or equal to min date, less than or equal to max date, and then do a calculate, I use that as my filter clause for my underlying table within the data model, and then I use, calculate the measure across that filtered table. Right? So basically the same code, but it turns out a little different. So if I go ahead and start recording and then refresh, let's do another one. Okay, so the no calculator approach, right? We're talking about 41 milliseconds for the DAX query, 66 in that case. Now the calculate version is, it's a lot faster than the original. Okay, I don't have the original up here for comparison, but we're talking, it's an order of magnitude or 2 orders of magnitude faster than the original calculate, the normal calculate that you would think of. That isn't using kind of those intermediate tables. But I can't say that it's 2 orders of, an order of magnitude, 2 orders of magnitude, closing in on 2 orders of magnitude, less performant, right, than the no calculate version. And it's pretty consistent, 1382 versus 46 milliseconds. That's a substantial difference, right? We're not talking about this is 46 and that, the other one is like even 120, which would be 3 times slower or something like that. We're talking an order of magnitude difference. And to me, that doesn't pass muster as far as something that is as performant, that was the original challenge, right? Create me a calculate version that's, reasonably within, performant. I'd say an order of magnitude doesn't qualify, in my opinion. So I would say that this solution is partially solved by Alexis Olson, and maybe Alexis, or somebody else that's really smart about calculate has a better solution than what I have, presented here. And this is the same for previous quarter, previous month, previous week. They're all basically the same. You get the same kind of performance disparity between the no calculate approach and the calculate approach. So that's the update. I would say after a week and a few days, it's still, I would not say a solved problem for the calculate camp. So, challenge is still out there, still waiting for a solution for this. That's really all I had for this video. Hope you enjoyed it, and I'll talk to you next time.